What? Ah, there you go. Okay. All right. Well, I hope everybody's having a good day today. A couple things. Let's see. Remember, I will not be here tomorrow. I'll be on campus, but I'll be conducting some IB CAS interviews for the seniors who were assigned to me. We'll continue on Thursday, but hopefully we're going to be able to make it pretty far today. If you didn't have the opportunity to turn in your assignment at the beginning of class, go ahead and make sure that you get that turned in before we take off today. I believe I'd have to check. It's either Thursday or Friday. I want to say Friday that we have our next quiz scheduled over number sets, sig figs, and the scientific notation. We're even going to go ahead and do a little exit ticket today on the operations with the absolute error, what we finished up with yesterday. We'll go ahead and do a few more problems, and we'll do that at the end. And we'll just really continue to see how far we get. We may or may not be able to start the next lesson prior to the end of the week, because what's happening next week? Remember, we were going to suspend teaching for the week during this class period. I'm just going to go ahead and give you the time. If you need a Chromebook or just the time itself to work on your strategies, your internal assessment, anything related to that. If you have any questions, an entire week, and then we'll go ahead and pick back up after that ends. Okay, so let's see what we got here. Yesterday, we started talking about error approximation, which is made up of absolute error, relative error, and percentage error. So absolute error is basically the difference between your values. Let me start over again. Absolute error is definitely going to be I cannot talk today. There we go. Absolute error is the difference between the value you believed it to be and the exact value that it is. There we go. So it doesn't matter how you subtract it, because we're going to have it in absolute value. Now, relative error is when you take the absolute error and go ahead and divide it by the exact value. Now, relative error tells you how far off you were in comparison to the real measurement. Now, percentage error is very much related to relative. You simply take the relative error and go ahead and multiply it by 100 to move the decimal over. You got your percentage. And we did this several times yesterday, and we got down to this right here. I believe we took care of part A. Then we just finished up B, right? Okay, so now if you're going to add or subtract values that contain error, adding and subtracting is the easiest operations you can. You simply add or subtract the exact values. Now, what you're adding or subtracting, remember, that's the absolute error. Like in this case, all of them have an absolute error of a 0.1. Now, whether you're adding or subtracting doesn't matter. You always add those errors. Okay, so in this case here, the y minus z, we subtracted 12.2 minus that 5.6, but we added the 0.1 plus the 0.1, which is where we got the 0.2. Now for b, we took care of the z minus x first, and in the division, along with multiplication, that's where it starts to get a little more unusual. You need to go ahead and find the relative error. So we're going to go ahead and take the absolute error. We're going to go ahead and divide by the exact. And what we did, we found those values, we added them up. This is the percent of the original value that we need to find. That is the error after the operation. Okay, so that probably sounds a little unusual. Let's go ahead and try another example. Okay. So we have x squared minus y squared. Now, the difference is going to be the easiest part to figure out, but we need to go ahead and find what x squared and y squared are going to be with the errors. So let's go ahead and do x squared. Now, when you're squaring something, you're just multiplying the value by itself, right? So for this one, why don't I go ahead and expand it? Let's say 5.3 plus or minus 0.1 times 5.3 plus or minus 0.1. Okay, now the first thing we're going to go ahead and do is just perform the operation with the exact values. So I need 5.3 times 5.3. Let me go ahead and get rid of this trig right here. So 5.3 times 5.3. So I'm getting 28.09. Okay, so I'm going to go ahead and say 28.09. Now for each of the values, what I'm going to want to do is find the relative error. I'm going to take the absolute error, that 0.1, and I'm going to go ahead and divide it by the exact value that we have, the 5.3. So I'm going to say 0.1 divided by the 5.3. Okay, and let's see what that would give me. 0.1 divided by 5.3. Okay.
Why? Would you explain that again? I'm sorry.
We're finding the relative error. So we're taking the absolute error and we're dividing by the exact value that we have. So the 0.1 divided by the 5.3. Just like on the previous problem where we were taking the y value, okay, we had that 0.1 and we divided it by 12.2. Amy, okay?
Yeah, sorry, I'm just writing it down.
That's fine. Okay. All right.
No idea how it ended up over here.
Okay, so let me go ahead and write this down. Now, it's not going to be the exact value. Let's go ahead and round it to 3 sig figs. So this would be 0.0189. Okay. So let's say 0.0189, just to go ahead and give me a value that I can work with. Now, here's the thing. You want to go ahead and do it for both the values that I'm going to multiply, but this one's kind of a unique case because both values are exactly the same. So what I can do is I could just go ahead and double this one right here. Because I would get the same thing from the other value, right? 0.1 divided by 5.3 would still give me this 0.0189. Okay, so I'm going to go ahead and multiply this by 2. All right, so I'm going to get 0.0377. Now, if I were to go ahead and find the percent error, I'd move the decimal over 2 places, so I'd get about 3.77%. Okay, but I want to take this percentage of the original operation that I found. You remember when we multiplied 5.3 times 5.3? I want to take this percent of that value, the 28.09. Okay, so I'm just going to leave it here because if I want to work with a percent, I need to make it the decimal value. So I'm just going to multiply this by the 28.09. Okay, so I'm getting 1.06. All right, and that is the error that I should have after performing the operation. So I got 28.09 plus or minus 1.06. Mm-hmm. Now, what I'm going to have you do, I want you to go ahead and try the same thing with y squared. Okay, so I want to multiply y times y. All right, we're going to run through the same steps. Let me go ahead and set this up. What was y again? 12.2 plus or minus 0.1. There we go. Okay, so think about what we did on the previous one. Okay, we apply the operation directly to the exact values. Then for each number, we go ahead and find the relative error. We take the absolute error and we divide it by the exact value. Oh, because you have to find the relative error of each value. But this one, you can kind of save yourself some time because you know being the exact same number with the same error, it's going to give you the same relative error. So I just doubled it.
So you would add the relative error of
Yes. You would normally add them, yes. That's exactly right. In fact, that's what we did yesterday at the end. Okay, so you may or may not be done, and that's okay, but let me go ahead and catch up to you. First, I want to multiply the exact values, whatever operation I'm provided. So I'm going to take the 12.2 times the 12.2. Okay. Or I could just say 12.2 squared. That doesn't matter. 12.2. All right. So I'm getting 148.84. Okay. So 148.84 plus or minus. Now, in order to find the error, I need to go ahead and find the relative error for each of the values. Okay, so I'm going to take that 0.1 and I'm going to go ahead and divide it by the 12.2. Control divide. 0.1 divided by, whoops, okay, 12.2. Okay, so I'm getting 0.00, let's say 820 if I go ahead and round it to 3 sig figs. 0.00820. 0.00820. Okay. Now, I want to go ahead and find the relative error for each of the two numbers, but as I was just talking to Ella, both of the relative errors would be the same because they're the same values, right? So that's why on the previous one, I just went ahead and doubled it. So I'm going to take that, and I'm going to multiply it by 2. So if I actually were thinking about what's the percentage error, what would that be? Yeah, about 1.64%, right? But I want to take that percent of the operation that we just did, the 148.84, the 12.2 squared. All right, so I'm just going to take that times the 148.84. Okay. And I'm getting 2.44. Okay. So 2.44. There we go. So this represents x squared. This represents y squared. And now all I want to do is subtract them. So is everybody okay with the operations up to this point? Anybody have any questions? Okay. Well, adding and subtracting is super simple. I want to take the exact values and just in this case subtract them. So 28.09, let's see here, 28.09 minus the 148.84. Okay. So that turned out to be a negative 120.75. So negative 120.75 plus or minus. And what do I do with my errors? Yeah, no matter if you're adding or subtracting, you always add the two errors. So I need a 1.06 plus a 2.44. Okay, so just 3.5. And there you go. That should represent x squared minus y squared. Okay. Are we ready for one on our own? Okay. Emmy? All right. Well, you'll notice it's already up here on the board. I'm giving you two values. So x is 11.2 plus or minus 0.1, and y is equal to 3.6 plus or minus 0.1. Okay. So what I want you to do with these is perform two operations. I want you to first find x minus y, and then I want you to find x divided by y. So x minus y and then x divided by y. Definitely the easier of the two is just the subtraction. This is just an extra problem I've got you. Okay. That is for when we get into a different topic in the notes. This one has a lot of different topics basically in one section. So one of the things we are going to talk about briefly is time zones. So while you guys are figuring those out, remember I'm not going to be here tomorrow, so the substitute's going to pass out a couple of things for you. He or she, I don't know who it is yet, is going to go ahead and give you the error approximation homework assignment. That's going to be due on Friday. And then you're also going to get an exit ticket over the homework we turned in yesterday and today, the number sets, the sig figs, and the scientific notation. So the exit ticket is due tomorrow before you take off, but the assignment, that'll be due Friday. Okay. And you guys can definitely work together. In fact, I encourage it. Okay. Uh, looks like Mr. Heinrich is doing some kind of math activity. So it looks fun. Oh no, I think that was a ladder that hit the ground. Okay, so I'll definitely go ahead and give you a little more time for the division, but let's go ahead and look at the difference. Remember, adding and subtracting is very straightforward. I've got the exact values of 11.2 and 3.6, so I just subtract those. What would that give me? 7.6. So this would be 7.6 plus or minus. Now, no matter whether I'm adding or subtracting values with error, what do I do with the absolute errors? I always add those. So the 0.1 plus 0.1 is just a 0.2. Okay, how many people got that for the first one? Yeah, adding and subtracting is very, very simple. Okay, now let's see if we can get the division. So let me give you a little more time. Okay, everybody ready? Or do you need a few more seconds? A few more seconds? Okay. So how many people are going to the Spurs game on Friday? Nobody? Okay, a few. Okay, because we're going to win, right? I was actually just wondering about this a little while ago. When was the last time Lubbock High had the Spurs? 2008? That's not too long ago. Only 11 years. That flies by. But the streak ends Friday.
The only time Lubbock High has ever won the state championship was when our coach died. What? Yes,
What?
there is like a little thing, and we have a trophy from like 60 something. Yeah, it's like a little triangle, and it's a trophy for doing the state championship. And it's because the head coach died, and that motivates the team to work hard enough to get to state and win state.
Wow. All right. Okay, well, let's go ahead and come back together. Now, here's what I got. Let's see if everybody matches up. X divided by Y, I got 3.11 plus or minus 0.114. Okay. How many people matched up with what I got? Okay, so that's not bad. That's not bad. There's several hands going up, but let's go ahead and talk about it. Okay, so the first thing, whatever operation you're going to go ahead and perform, like here I want division, I'm going to go ahead and divide the exact values. So I'm going to go ahead and take the 11.2 divided by 3.6. Okay, let me go ahead and clear this out. So 11.2 divided by 3.6. Okay, whoop, did not take the 2 there. All right. So here's where I got the 3.1 repeating. So I just said 3.11. Okay. 3.11 plus or minus. Now's where you got to do the extra work to figure out what the error would be if I were to divide with the original errors. So for each, I'm going to go ahead and find what error. Starts with R. The relative error, okay. So I'm going to take the absolute error, the 0.1, and I'm going to go ahead and divide it by the 11.2. Okay. Then I'm also going to find the relative error for the other one, 0.1 divided by 3.6. Okay. So let's go ahead and see what that's going to give me. 0.1 divided by 11.2. 0.1 divided by 11.2. Okay, this is going to give me 0.00893, let's say. 0.00893. 0.0893. And then let's do the same thing for the other one. It was divided by 3.6. Okay, so control divide. 0.1 divided by 3.6. So for this one, I got 0.02, let's say 78. 0.0278. Okay. Now, each of these represents the relative error. If I were to multiply by 100, that would be the percentage error that original 0.1 represented. But again, to work with these, we need them in the decimal form. So here's the relative for the first one. Here's the relative for the second one, x and y. I want to add those up. Okay. So I'm going to go ahead and take that 0.027 plus, let me highlight that guy right there. So I'm going to get 0.0367. Okay. Just then we'll go back. So 0.0367. Now, if I were to go ahead and find the percent error, that would be about 3.67%. That's the percent that I want to take of this original operation value right here. Okay. So I'm going to leave it as a decimal. I'm going to take that, and I'm going to multiply it by, and instead of using just the 3.11, I'm going to go back here and just use the exact value that I have in the calculator. Okay, 0.11419, so I just kept these in 3 sig figs. Okay, 0.114. There we go. Okay, did we get close? Where was it that we made a mistake? Okay. Did you want to go ahead and try one more? Now, I haven't worked this up yet, but we could work it together. We could say x times y. You want to try another one? Okay. Kate, did you have a question?
For clarification, so for defining the relative,
The relative error?
yes, sorry,
Mhm.
you only do it on multiplication and division.
Yes, you don't have to worry about that for addition or subtraction. When you add or subtract these values with errors, you just automatically always add the errors. Okay, only multiplication and division. Okay, so let's try this one together. Let's say I want x times y. So 11.2 plus or minus 0.1, and I'm going to multiply that by 3.6 plus or minus 0.1. Okay, so I know I'm going to erase some things I need, but I'm just going to go ahead and start all over again. Okay, so you guys walk me through this. Let's say I want x times y. What's first? Okay, so I actually need the exact values. So 11.2 times 3.6. So 11.2 times 3.6, what am I going to end up with? Okay, so let's say 40.32. All right. So 40.32. Now here's what's really nice. That is already half your answer. You've already performed the operation on the exact values. Now we just need to go ahead and figure out what the error is if I were to multiply. Is everybody still with me? Okay. Well, how do I do that? 0.1 times divided by. So we take the absolute error and we divide by the exact value to get the relative. So again, for each of these, I'm going to take, that's a 0.1. I'm going to take the 0.1 divided by 3.6. I'm going to take the 0.1 divided by the 11.2. And I remember I said I shouldn't erase those, but what are you going to do? 0.1 divided by, whoa. Let's go here. Interesting. So 0.1 over 3.6. Okay, so I got 0.0277 repeating again. If I want to go ahead and take the 0.1 divided by the 11.2, okay, got that same relative error. So I'm going to add these. That's the percent that I need to go ahead and take of the original operation. So I'm going to take this, okay, plus this right here. All right, so there's that same 3.67%. Now remember, I'm going to multiply that by what? What did we get when we took the 11.2 times the 3.6? Okay, that original value that we got, 40.32. So I'm going to multiply 40.32 So I'm getting 1.48. There we go. We multiply, once we get these values here that we already had, we take that total and we multiply by the original number from the original operation. See, because we're ultimately wanting to multiply these numbers, so I took the exact values 11.2 times 3.6. Remember on the other one, I multiplied that percent times the division of the two. That's where I got to 3.11. How we doing? Okay. All right, just takes a little bit of practice. So we'll go ahead and stop and do one of these on our own in just a minute. There we go. Let's at least see if we can get through one more problem. We're definitely not going to go ahead and make it to the time zone problems today, but that's all right. We'll go ahead and do that on Thursday. The next problem, it says, use the formula A equals 2b plus c squared divided by 2d to evaluate for A if B equals 5.25, C equals 3.63, and D equals 1.35. Approximate the value of A to the nearest whole number without using a calculator. Okay. Now it says to the nearest whole number, so we can actually go ahead and round these prior to substitution. Like, what's the nearest whole number if B equals 5.25? Yeah, so that would just be 5. C, 3.63, what would that be? 4, and then 1.35 would be 1. Okay, so if we go ahead and do this, A would equal 2 times B, so that's 2 times 10. Bleh, already thinking ahead, 2 times 5. Plus C squared, so plus 4 squared over 2 times D, well, that's just 2. All right, so 10 plus 16, what's that going to give me? 26 divided by 2, we're looking at 13. Okay, so what's the relative error associated with this approximation? Okay. Yeah, now we just go ahead and do like we would before. Now we need the exact value. Okay, so let's see here. What was it? 2b, or not 2b, right? Yeah, okay. So let's see here. It was control divide, so it was 2 times, what were these values here? 5.25, 5.25. Then it was minus or plus? Plus, then it was 3.63 squared. Okay. And then we were dividing that by 2 times d, and was it 1 point, what was it? 1.35. Okay, would everybody agree? So here's the exact value. Okay, so I'm getting like 8.76922. Okay. So originally, this is my approximated one, so this is V sub A. The exact value is equal to, I'll just go ahead and write this in 3 sig figs. So that would be 8.77. 8.77. Now what I want to go ahead and do is find the relative error. But in order to find the relative error, what do I need to find first? Remember the absolute error. So that's going to be, okay, the absolute value of 13 minus the 8.77. Okay. All right. So I'm going back over here to the calculator. Where do I find absolute value? And it's not really necessary here because it's going to give you a positive number anyway, but where do I find it? There you go. Between 9 and the catalog, this button right here below delete. Second row, first column. Okay. So I'm going to go ahead and say 13 minus, and then I'm going to highlight that previous decimal. Okay, plug that in. So I'm getting the absolute error to be like 4.23. Okay. So I'm going to take that absolute error, the 4.23. Okay, and what do I do in order to find the relative error? Divided by what? There you go, divided by the exact value. Okay, so let me go ahead and write this out, what I put there, 8.77. Now again, I'm just rounding to 3 sig figs to go ahead and show what I'm doing, but we're going to go ahead and use the exact values in the calculator. So I'm going to take that guy right there, I'm going to divide it by that exact value. Okay, so I'm getting like 0.482. Okay. Okay, and there you go. That would be the relative error. So what's the percentage error if I were to go ahead and move that decimal over? 48%. So there's actually quite a large error here if you were to go ahead and round it opposed to doing it exactly. Okay, but big picture, is everybody starting to feel better with absolute error, relative error, and percentage error? Is anybody having issues? Okay. All right, so I'll tell you what, since we're not going to make it to anything else anyway, let's go ahead and stop today. If I can get you to take out a sheet of paper, we're going to go ahead and have a little additional exit ticket before you take off.